Hey guys, we're back with part 3 of the NCEA Level 1 Tables, Equations and Graphs exam form 2020. Now this is actually a week after I recorded the last 2 videos. I did record the 3rd video last week, however it was half corrupted, so I'm going to have to re-record this entire thing again. Now I've already also recorded the marking of the test. So things are a little bit weird, and when it comes to marking, you're going to see some things that aren't quite right because it was all based on what I did last week. So we're going to go through the work again, so let's get into it. So before I get started, I'm actually going to go and erase all of the stuff that I did last week because we're gonna have to start from scratch. So here we are, I've just deleted everything that we did last week and we're gonna jump straight into it. So it says here, using the axes below, sketch the graph of y equals 3x minus 1. So on our paper here, let's write up a bit of a table. So we have some x values and some y values. Now the x values we can see start at -2, so we're actually gonna start at -2, then we go to -1, and we're just gonna go up to some of these values. -1, 0, 1, 2, 3, and 4. I'm not actually going to do the last one. Now we're going to take x and we're going to plug it into the equation given here. I'm just going to rewrite the equation because I do like to see the equation written in my own handwriting and I can focus straight on it. 3 to the power of -2 minus 1, that -2 is our new x value. That's the same as 3 to the power of -3. Now 3 to the power of -3 is actually the same as 1 over 3 to the power of 3, which is 1 over 27. Now we can't see 1 over 27 on this graph. That is way too tiny. 1 over 27 is a really small number, so that's like really close to the x-axis. So that's that first one done. Now let's go to x equals -1. 3 to the power of -1 minus 1 equals 3 to the power of -2. Well, that's the same as 1 over 3 to the power of 2, which is equal to 1/9, because 3 to the power of 2 is 9. So 1/9, that's our next number. We'll just put that in here, -2. 1/9 when x equals -1. 1/9 is also really, really close to the x-axis, so that's around about there somewhere. I'm not being super accurate because it's really difficult to be super precise with these tiny numbers. The next one, x equals 0. 3 to the power of 0 minus 1 equals 3 to the power of -1. That's the same as 1/3. 1/3 is about the third of the distance from the origin upwards, so around about there. Next one, 3 to the power of 1, 3 to the power of 1. X equals 1 is the same as 3 to the power of 1 minus 1. 3 to the power of 0. Well, that's the same as 1. Anything except 0 to the power of 0 is 1. So at x equals 1, y is 1. So there's our next point. If you don't want to go through this process of listing out all the numbers one by one, you can get out your handy dandy calculator, open it up, go to the run setting and type in 3 to the power of, and then in brackets, because this is one group up here, in brackets we write x, whatever the x value is, so in this case 2 minus 1, close that bracket and press execute. It is 3. Now if you're even lazier than that, and you should be, go to your table setting on your calculator, press execute, and we're just going to type in the equation we see up here, almost exactly as it is, but with some brackets. So 3 to the power of, not that button, 3 to the power of, then a bracket, then this x minus 1. Press execute. Our set button is right above F5, so we're going to press F5. We're going to start, well, we don't have too many numbers left, so let's start at, let's start here at x equals 1. And then we're going to end at x equals, 5 is fine. I'm just going to move this table across a little bit, right to there. Press execute, and it gives us our table of values. 1 and 3 we already have right here, 1 and 3. Then we have 9 and 27, and the last number is 81. 9, 27, and 81. Now we're going to plot these points on the graph and then join them up with a nice smooth line. There it is. There's our points. Let's get out a nice smooth line, and we are going to join all those values up with a nice smooth line. Doing my best to make sure it looks all right. That looks pretty good. I'm very happy with that line. Let's just nudge this down a little bit so it crosses. So that is question number 1 complete. Let's move on. Sorry, question A complete from question 3. Let's move on to the seabird. A seabird's flight path is shown in the graph below. The bird takes off from the cliff at point C. That's right here. The bird initially follows a path described by this curve, where x is the horizontal distance in meters, that's this direction, from the cliff, and h is the height, the vertical distance in meters above the sea. The bird changes direction right here at point D, goes into a diving motion, heads on down that way, and follows a straight line path until it hits a sea level at point S down here. Point S is 10 meters from the base of the cliff. So this distance noted here is 10 meters, noted by the dotted line. What is the greatest vertical height that the bird reaches above sea level? So for this, all we need to do is take the equation. Let's write out the equation somewhere. I'll just pop me over to the other side. Write out the equation. H equals negative 1.5. I like to write it out in my own handwriting, as you know already by now. Plus 15. Okay, so the greatest height in this case is this number here, 15. The greatest vertical height that the bird reaches above sea level is h equals 15. So 15 meters. That is our answer. Now, this format that we see that I've written up here, this is called vertex form. And this is the whole point of vertex form, is so that you know where the turning point is. In this case, it was at 15. Vertex form tells you where the vertex is. That's the nice handy part about this, this form. Okie dokie. Next, it says find the equation of the bird's flight path when it follows the straight line diving section from D to S. Okay, we're going to find the equation of the bird's flight path. So we have the point 49. We also have the point here, which is 10 across and 0 on the y-axis. Now you're going to see me make an error in the marking thing. So you're going to see me make an error right there, and you can, just keep that in mind. I'll talk more about that later in the next video. So find the equation of the bird's flight path when it follows a straight line diving angle section from line D to S. So we have our delta y over delta x, in other words, our rise over run. How much do we rise? Well, it's a drop. So we're going from here and we're dropping towards the sea. Our numbers for the rise are these second numbers, 9 and 0. So we have 9 minus 0. And then our run from left to right is 4 and 10. 4 minus 10. 9 minus 0 is 9. 4 minus 10 is negative 6. So we end up with negative 9/6 or negative 3 over 2. So our gradient is negative 3 over 2. But we're not done, because an equation has the form y equals mx plus c. Now we already know m. Let's just place that in there. Y equals negative 3 over 2 x plus c. Now we just have to find out what that c value is. To do that, we can take either these coordinates or these coordinates and substitute them into this new equation that we've just come up with. So let's go ahead and do that. I'm going to use the numbers 4 and 9 for this. So we'll take the equation y equals, can we see that? Yes, negative 3 over 2x plus c. Now, just shift that across a little bit. There we go. Now we're going to take the numbers 4 and 9 and place them in their correct places in this equation. So the y value is 9. The x value is 3. And the c, we don't know what that is just yet. So we end up with 9 equals negative 9, that's 3 times 3 is 9, divided by 2 plus c. Have I done something wrong? Yes, I have. That's a 4, not a 3. This one here needs to be a 4. That means that this number here is 4 times 3 is 12. So we have 9 equals negative 6 plus c. C equals, well, negative 6 plus what equals 9? C equals 15. So our final equation is y equals negative 3 over 2x plus 15. That's our answer. I'm going to highlight that, give it a little box, and we are done with that question. There's our equation for the straight line diving motion from D to S. Okay, next up, another seabird takes off from the cliff. It follows a similar parabola-shaped flight. How might the different flight path of the second bird be shown in the equation compared to the equation of the first bird's flight path? Okay, so the first bird's flight path is determined by this, and that's, I think we're just talking about the parabola. Yes, it follows a similar shaped parabola. It follows a similar parabola-shaped flight path. So we're just looking at the parabola part, which is h equals negative 1.5 multiplied by, what was it? X minus 2 squared plus 15. So there's 3 main parts to this. First part is this part here. The negative 1.5 dictates how steep the curve is. So instead of being like this, if we have a larger negative number, it might be like this. If we have a shallower negative number, like negative 0.5, it'll be like this. A larger negative coefficient will give a steeper graph, steeper parabola shape. A smaller negative number, negative coefficient, a smaller coefficient will give a shallower parabola shape. Okay. Then we have 2 other parts. This part here is our negative 2. So that's our left-right shift. So if we have the bird, instead of starting from here and going up, let's just use a different pen to, perhaps we could shift this across and make it start here. But that will start the bird at a different place, but it's just been shifted to the left. The same shape, just shifted. And that's allowed. We could also shift this one across to here, but in that case they won't start at the cliff, so their parabola shape might end up something like this. And we'd need to talk about that. I'm not going to write it down because I explained this in the following video, so just catch up and wait for that. So that's another option. The third option is this number on the end, this one here. So just to recap, this x minus 2 part shifts left, right, and this plus 15 on the end shifts up and down. So if it's a smaller number like 10, then it will shift the whole graph down. If it's a bigger number like 20, it'll shift the whole graph up. But keep in mind, it's important that the parabola does not change. The parabola shape does not change. It's just being shifted upwards. But that means that we now have to start somewhere else on the cliff face. Otherwise, it'll be shifted downwards. So same parabola, but shifted downwards. And again, we start at a different place on the cliff face. Make sure you include that little bit in your explanation, that it changes the position of the cliff face if we move up and down or left and right, but not if we change just the coefficient of the parabola. The next one, a farmer wants to set up 3 rectangular fields of equal size side by side. He has a total of 120 meters of fencing for this project, and he wants to find the setup that maximizes the total area of the fields. The required setup is shown below. Now, I'm going to set this up with y being vertical, because y is usually vertical on our vertical axes. And there's actually 4 of these y's, because we have intermediate gaps here. We also have this this distance across, so I'm going to call that x, just like our x-axis goes across. Use tables, equations, and graphs to investigate the relationship between the total area of the fields and the lengths of the various fences he could use. Now you see that I've got some stuff down there. I'll talk about that in a second. So let's say that we have an area. Now the area is the area of this plus the area of this plus the area of this. So that would be x times y. This entire length multiplied by the height is x times y. But we also have a perimeter, and the perimeter is this top x plus this bottom x plus 1, 2, 3, 4 y's. So we have 2x plus 4y. But we're also told that he has 120 meters of fencing. Now fencing goes around paddocks, so that is equivalent to our perimeter. So our perimeter here is 120 equals 2x plus 4y, because the perimeter is 120 meters. Now there's a factor of 2 in here, so I'm just going to go ahead and divide everything by 2, giving us 60 on the left equals x plus 2y. So I'm just going to rewrite all of that over here. 60 equals x plus 2y. We already have area equals x times y, so area equals x times y. Now, I'm going to take this equation here and I'm going to rearrange it so that x is left all by itself. So let's minus this 2y from both sides of the equation, and we end up with x equals 60, that hasn't changed, take away 2y. Let's substitute this into this equation. We now know what this x is. X is 60 take away 2y, so we can take all of that stuff and replace this x with the 60 minus 2y. So our area, let's push this up a little bit. Area equals x, which is 60 take away 2y, multiplied by y. We can simplify that just a little and call that area equals 60y take away 2y squared. And I'll just tidy that up just a little. And our area is 60y take away 2y squared, and that's it from me. I'm going to hand it back to me from a week ago, and he's going to continue this problem. Hey, so my computer paused there for a moment, so I'm not sure what happened, but we're going to continue anyway. So we have this equation, and we can even expand this out, giving us 60y take away 2y squared. So down here in the table, we're going to set up a list of x values and y values with perimeters and areas as well. So we have x and y. We can also do the area, which is this equation here, and the perimeter. Do we need the perimeter? Not really sure, but we'll give it a shot. So x and y, well, the minimum x value we could theoretically or mathematically have is 0. Now, if x is 0, then there'd be no size. So we'd just have a length of fence that was all just completely squished, and we wouldn't be able to fit anything into the farmer's paddock, whatever they're trying to use. Our y value we can get from this equation. So our y value, actually, let's set it up the other way around. Let's say that y is equal to 0. Again, this time it's just flattening it instead of going the other direction. And now we can work out the x value from here. So if y is 0, then we plug that into this equation, and we get x equals 60 take away 2 times 0. 2 times 0 is just 0, so 60 take away 0 is 60. If y is 1, then we get 60 take away 2. 60 take away 2 is 58. If y is 2, 2 times 2 is 4. 60 take away 4 is 56. And hopefully you've seen a pattern emerging going down here. We're just taking 2 away each time. So let's just fill that in, knowing what each bit will be from here on out. Okay, for the areas, we'll just take our area here and use our y values to calculate what our areas will be. So for an area, with a y value of 0, we end up with our squished, or our fences all lined up next to each other, and we get an area of 0. For an area of 1, we get 60 take away 2, which is 58. for an area of 2. Now it gets a little bit more complicated. 60 times 2 is 120. Take away 2 times 2 squared. So that's 8 here. 2 times 2 squared is 8. 120 take away 8 is 112, I think. Let's just get out our calculator and we'll let the calculator do the rest of the work. Okay, so in our calculator, just like last time, we go to our table setting and we type in this equation here. 60 times, now it says y here, but we're actually still going to use the x button. X is just the set variable in the calculator. Take away 2 times x squared. Even though it says y squared there, it is x squared because of the way that the calculator is set up. Now we're going to set this starting from 0. And we're going to end at 12. That's our biggest number in the y column. And our step is 1. Oops, I put 11 there. Our step is 1 because we're going up in ones each time down this list. There's all our values. We have the first 3 correct. Now we just need to put in the rest of them. Okay, so at this stage we see that the areas are increasing and increasing and increasing, so it doesn't actually look like we've reached the maximum just yet. I think what we might do is we won't actually use this column for perimeter because the question doesn't actually anywhere ask here for the perimeter. It just wants the area. So the perimeter was just to set up the equations, and now we're going to calculate the maximum area. So on this second column, I'm actually going to start with y again and area again. But instead of starting from 0 for our y value, we're just going to continue the list up here. So we're going to start with 13 and so on. In our calculator, we'll do the same thing as what we did last time. But this time, when we go to our set parts, we're going to start at 13 and we're going to end at 25. So 13 up to 25. Press the table button and there's all of our numbers. So we just need to copy these over to our table. For those of you that have got a bit of a keen eye, you might be able to see that we're now going downwards in our numbers. And this number is the same as this number. That's the same as that. The next number up is actually over here. 432 is the same there. 418, they're the same. So it's symmetrical either side of 450. And we can continue just reading these numbers here and copying them into our list. There's our list of values. If we go back to the calculator, our last number should be 250. There it is, 25 with 250. So now we can go ahead and put this onto the graph and then finish up with a conclusion. Okay, so on this graph, there is no axes given to us. So we need to put our own axes in for x and y. Now the x values, interesting. What kind of graph is this? It says x and y, but that doesn't mean we have to follow my x and y's that I've created over here. We can instead set this up as y and area. So let's set this up as length versus area. On the length side of things, I'm going to go from 0 up to 25. And on the vertical axis, the area, we're going to start from 0 and go up to a maximum, looks like it was 450. So we'll get up to 450 on the y-axis. So I'll set that up and then start plotting the points, and then we'll come back for a discussion. Okay, there's our points plotted for our parabola. Now we just need to join all of those up with a nice smooth curve. There we go. That is our parabola. So we can see both from the parabola that we've drawn there and from the table that our maximum occurs at 450 square meters with a a height of 15 meters. So let's just conclude that up the top here using everything that we've learnt so far. Okay, so we've got most of it. The maximum area is 450 square meters. When we have the side length, that's these lengths here, is 15 meters. But we also need to know what the long sides are. That's these ones here. So we're just going to take the equation down here. X equals 60 take away 2y and substitute the value for y that we found in this whole process. So we found y was 15 meters. We can see that over here. So 60 take away 2 of those. 60 take away 30 being 30 meters. So the maximum area is 450 square meters when we have a side length of 15 meters and the long sides being 30 meters. And we are done. So that is the tables, equations, and graphs assessment for 2020. In the next video, we're going to go through and mark all of this to see how well we did. But before we get there, if I made any mistakes, let me know down in the comments of this and you can get some bragging rights.